Let's look at problem 76, minimum window substring. First, let's read through the problem. Secondly, let's look at several of the examples. And lastly, we'll give a solution using two-pointer sliding window method. So this is a continuation of problem 3. Actually, it's a similar idea. So first, let's look at the problem. Given two strings s and t of length m and n respectively, so we are required to return the minimum window substring of s such that every character in t is included in the window. Here, it includes duplicates. In other words, we also count frequencies. If there's no such substring, we will return the empty string. So the next paragraph is said that the test cases are generated such that the answer is unique. And another point we are going to notice is that here we are talking about substring rather than subsequence. So a substring is a contiguous subsequence of characters within the string. Before looking at the examples, let's look at the constraint. So the strings s and t had length greater or equal than 1, which means they are not empty. And also they can up to 10 to the power 5th in length, which means if we come up with algorithm which requires say n square time complexity, it may not pass the test cases. So this is the problem statement. So now let's look at some examples. Before looking at the example, let's emphasize, so the method we are going to use is the standard two-pointer sliding window method. So the main idea is for each index, let's call it R. So we find the minimum window substring that satisfies the condition in the problem. And the condition of this problem is that so the minimum windows contains all the characters appearing in T and also the frequencies match. So that's the method and main idea. Let's look at the example. So let's look at example 1. So we have S is given by this long string and T is given by ABC. So for example, for this index corresponding to last character C, so B, A, and C is a window which has length 4 and it contains all the characters in T and all the frequencies match. Here notice that character N actually does not belong to T. So in this case, the problem returns B, A, and C, so with a length 4. So actually, if we look at another index, for example, look at this index corresponding to this letter C, then a window that satisfies the condition in the problem is A, D, O, B, E, C. So this window, or this corresponding to the index at this letter C, satisfies the condition. However, the length is 6, so which is not minimal compared with this one, B, A, and C. This is the return. So let's look at another example. Just say S equals the A, B, A, and T equals the AA. So for this problem, A appears in T and with a frequency 2. So in order for the window, minimum window, to contain all the characters with correct frequency, we're going to need all the string S. In other words, we're going to return ABC. with the minimal window size that is 3. So if we change a little bit, if we change this S to be ABAA and T equals AA, then a minimal window corresponding ending at this index corresponding to this letter A is AA. So this is the result we are going to return, and the length is 2, right? So with this several examples went over, so we can actually run the standard two-pointer styling window method. So as we mentioned in problem 3, here we are going to use a while loop representation of this method. So again, the idea is to, for each index, we try to find the minimum window substring that satisfies the condition. If there exists one such window, right? Then we scan the string S from left to right. So let's first do this. Here, because S and T are non-empty, it actually eliminates quite a number of edge cases. For example, S or T is empty. In this case, if it were allowed, so we can just include by if not S or not T, so we just return empty. So, but here let's comment it out. So first we have a target. So the target is the unique letters appearing in T and their frequency. So let's do a counter first. The target is, let's call this collections counter function. So with T, right? So this the target we're going to achieve. So also we need how many unique characters we need to count. So let's call it required. So it's the length of target keys, right? So with that said, let's set up the standard sliding window. So we have 2 pointers, L and R. So we initialized at 0 and 0. And for convenience, I will introduce another variable called N, which is the length of S. So to get the minimal window, we'll initialize a result tuple, which I'll use float infinity to record the length of the current valid minimal window and its corresponding starting and ending index. So you can see this means length, less start index and end index. So corresponding to L and R. So in order to check the conditions, we introduced a window dictionary. Let's call it dict. At the very beginning, it's empty. So now we can enter the while loop. So while R is less than N. Then we check the character and update the window. So the character is S, R. So we update the window like this. So window. So we try to get if this character is inside the window. If not, we will set a default value that is count is 0 and plus 1. So in this case, as we add more characters to the window, we want to check if the adding of new characters formed and satisfy the new characters and their frequency. So here is a check: if character in target and window character equals target character, then in this case the formed ones are going to increase them by 1. So before we do that, forgot to let's introduce another variable that's called formed. So originally it's 0, right? So if character is in target and the window character arrives at the count in the target, so we increment formed by 1. So now let's do the shrinking of the window from left to right. So well, L less or equal than R. So here notice that we have less or equal, and formed equals required. So this is the condition that the problem requests. So if this is the case, let's first check if R minus L plus 1, that is the current window length, is less than the result, the length in the first element, corresponding to the first element in the result tuple. So if this were the case, we are going to update the result by, so the length will be R minus L plus 1, and the left index, the right index will be L and R respectively. So if after we check, we can shrink the window. In other words, we move the left pointer to the right. We try to move it to the right. So let's, for convenience, we introduce this. This is SL. So in the window, the character count is decremented by 1 due to this move. And then we check if character in target and window character now is less than target character. So if this were the case, the formed is decremented by 1. In other words, the number required unique characters may not achieved. Yeah, after this check, we're going to update the left pointer by 1, and then as we jump out of this while loop, we are going to update the right pointer to the right by 1. So once we have done, so we are okay to return the result corresponding to the requirement in the problem. So the problem requires to return the corresponding window. So we are going to return result. The starting index is 1, and the ending index is 2, right? So yeah, in this case, if we have a valid window, in other words, this is not the one we preset. Otherwise, we are going to return an empty string. So let's first check if this solution works. So we run the code. So this is the test case. So let's do this one. It passes, and let's try another one. Let's try let's see, ABA and AA. We should return ABA, right? So this is ABA, and then we modify a little bit. We should return AA in this case. So if we like, actually we can also print the result itself, so that we know the starting index, ending index, and the length. So for example, for this one, let's see. Yeah. So it means the minimum window has length 2, and it starts at index 2 and ending at index 3. Let's do it for this problem also, this example. So yeah, it says that the minimum window has length 4. It starts from index 9 and ending at index 12. Okay, so let's check the generic case. Alright, so yeah, this is one example of the two-pointer sliding window method, similar as problem 3. So that's it. Thank you.